Okay, in this presentation we're going to look at a programming exercise known as the mouse in a maze problem. First off, we are using Jupyter notebooks and we are using Julia version 1.6.1, and also at the top you might notice here that we are using the statistics package. So I use the package manager pkg.add at the command line, the Julia command line, just to load up that package. So using statistics. Now I'm going to just sort of save that for later on because we're looking at means and so on. So the mouse in a maze. A mouse is in a room with 4 exits at the center of a maze. Okay, and the mouse has to find its way out. So there's 4 exits: A, B, C, and D. Now exit A will lead directly out of the maze. Well, not directly, but it's the right answer for getting out of the maze, and it will get out of the maze after 4 minutes if the mouse takes that route. Exit B will lead back to the room after 2 minutes, exit C will lead back to the room after 5 minutes, and exit D will lead back to the room after 6 minutes. Each time the mouse makes a choice, it is equally likely to choose any of the 4 exits. So it doesn't really remember what it's doing, or it doesn't understand what it's doing. I'm not sure how realistic that is. Maybe mice are more intelligent than we think. But anyway, let's just assume that each choice is equally likely. Let t be the total time taken for the mouse to leave the maze. Calculate the expected value of t, and also what we might do, so yeah, find the expected value of t. And just actually an additional problem, starting at the room, find the probability that the mouse escapes in exactly 10 minutes. Okay? So, what we're going to do here is just sort of set up things bit by bit. So here I'm going to set up a little vector there, A, B, C, and D, and this is a vector of 4 strings, A, B, C, and D. Okay, so this is what we're going to, the framework we're going to sort of solve our problem from, or using mathematically. Also, what I'm going to do here is a random selection of one of the doors, or one of the exits, I should say. Okay, so I just say door 1, door 2, just to sort of, anyway. I should have said it, the exit. So around 1 to 4, that just randomly picks a number there between 1 and 4. And this will sort of be how we decide, make the decision for the mouse as to what door it is going to go through. Okay? So, choose door is just pick a door, one of the 4 doors, and in this instance it chooses B. Let's just run it again, see if it chooses B. No, this time it chooses D and B, and so on. Each of the 4 doors are equally likely. Now, so we're going to sort of build up this problem. So a starting condition is that the mouse is in the maze and remains so until they go through exit A. So this is just a starting condition we're going to use. In maze is equal to true, okay? And if it turns out that they choose the door exit A, then that will switch that to false. Okay, so this is just how we would sort of start building this up. I'm just going to sort of build it up incrementally. So we're just initializing in maze is equal to true, then we're choosing a door, choose door equals doors around 1 to end. Okay, and if the chosen door is equal to A, that means we switch in maze equal to false. Okay, so let's just have a look at that. So see, it is still in the maze. Let's just try that again. A, false, it's outside the maze now. Okay? Both of the 2 operations I just carried out, they're independent of each other. So we have to build a way of sequencing them. Okay? So let's set up a while loop here. Okay? So what we want to do here is account for all the time taken and account for the fact that the mouse is in the maze. Okay? So we're going to set up a while loop here. Okay? And what we do here in the first instance is choose a door. Sorry, just actually to remark that we are in the while loop if in maze is equal to true. So we're going to keep going if the mouse is still in the maze. Okay? And what we're going to do here is assume that it's, or choose a door. Okay? And if it chooses door A, the time taken to leave will be 4 minutes, so it just goes out and it's outside the maze. So essentially what I got here is an if statement for each of the 4 doors and what happens in each of the cases. Okay, so each of the 4 doors, if each of the 4 exits has something very similar going on. If choose door is equal to A, the time taken just is incremented by 4, and then it's outside the maze. In maze is equal to false. If choose door is equal to B, the time taken is incremented by 2, but it's still in the maze. Likewise, if in choosing door C, the time taken is incremented by 5, but it's still in the maze, and so on. So that's a very simple construction there, and you will probably find more elaborate or tidier ways of doing that as you progress. This is just something for beginners, university students, undergraduates, and so on. What we want to do here is, while our while loop is running, what we might do is actually just sort of keep track of what's going on. This is very good for getting used to while loops. Okay? So the end condition is that if the hit chooses door A, then it leaves the maze. Okay? So we need a logical condition to trigger the end of the while loop. Okay? And it's to trigger the end of the while loop basically when this condition is no longer met. Okay? So when it chooses door A, in maze is set to false, and that triggers the end of the while loop. So let's just run that there. Okay? So in this instance, it was pretty quick. It chose door B. In the first case, then it chose door D in the second case, and then it chose door A in the third case. So it took 12 minutes altogether. Okay? So let's just run it again and see what happens. So I'm just going to run the cell. So B, CCA, 16 minutes. CBA, 11 minutes. And let's just run that again. Oops, gone too far there. 11 minutes. Okay. So that component there is going to be the main engine of what we're going to do. Okay. I'm not going to use the print statements anymore. But what I'm going to do here is set up a while loop, a for loop, and around what I have just have above there. Okay. So what I'm going to do here in each case is sort of store the time taken in each of the iterations I'm about to do. And I'm about to perform this experiment 1,000 times. In fact, let's go for 10,000. Okay. So this is the for loop here for I in 1 to n, where n is 10,000. We're going to carry out our little experiment here. Okay. And then when each time our experiment is run, we will save the time taken into that vector there called times distribution, which is just saving up the times that we are taking. So push bang or push exclamation mark. Okay, that just updates it. So let's run that for a second. So there we have it run. So what we're going to do there is just look at all of the possible values there. Okay. Now, essentially, sort of unique time distribution. I'm just really getting a sense of what's the minimum and what's the maximum values there. So that's not the distribution there. But it's possible that it could go for 149 minutes. It could be stuck in the maze for hours, essentially. Okay? So, what is the probability that it takes 4 minutes? It's about 25%. Remember, this is out of 10,000. Okay. What's the probability that it takes 10 minutes? About 6%. Okay. And let's just have a look at our distribution here. So sort that out. There we go. And let's just get the mean. So that is 17.07. Okay. And the median, I think, should be about 10 or 11 or something like that. There we go. All right. That's it. We'll leave that there.